It's a pretty safe bet to assume that in the future we will always be able to produce electricity. We can make electrochemical cells and batteries using any two metals connected to some type of electrolyte material to produce direct current. To produce alternating current, all we need are magnets and wires. Magnets and wires, and put them in motion. So it's fairly simple to make your own hand crank generator. Here I have a lot of wire going around a little old film canister that I cut up, and on the inside of it I have some strong neodymium magnets. They're connected to a wire that serves as a hand crank. As I crank this generator, and that's what we call a device that converts mechanical motion into electrical energy. So this is a generator. I am generating alternating current. All I have to do is keep cranking this. Well, the faster I crank, the more coils of wire, the stronger the magnets, the more current we're going to generate. So we need to find ways to produce this motion that's inexpensive, gives us what we need, and doesn't harm the environment. So some of the ways that we produce this motion is, instead of cranking it by hand, we can put a paddle wheel on there and let a waterfall flow over it. And the waterfall will crank this to move the magnets and wire relative to each other. The first alternating current power plant was actually built at Niagara Falls, and it's still in operation today. We can also make this a propeller instead of a crank, put it up high into the air, and let the wind blow it in order to generate electricity. That's how our wind turbines work. But water and wind aren't always so consistent. So in order to have consistent movement, we can burn something to boil water to make steam and have high pressure steam jets cause this motion. And so our oil, coal, and natural gas power plants simply just burn the oil, coal, or natural gas to boil water to make steam, and then high pressure steam jets will cause this motion. Nuclear power plants. We don't get electricity from nuclear reactions. We get heat from nuclear reactions. And so those nuclear reactions will generate heat, which will boil water to make steam in order to turn these turbines. So those ways of generating electricity all have their pros and cons. Some are less expensive than others. Some are not renewable, some are, and some do more and some less harm to the environment. So finding a right balance to serve the world's electricity needs is an important task now and for the future. These science supply catalogs will sell hand crank generators that are made the same way this one is, with coils of wire and magnets inside of here, and you turn a crank to generate the electricity. These have gears in there in order to make, when this thing goes around one time, inside of there it goes around multiple times. So you generate a lot more speed by having it geared. So one thing to notice, this thing will spin freely whenever it's not connected to anything, but if I connect it to something, like I'll just connect these two ends together, and now I crank it, it's much more difficult to crank. You can actually feel the force that it takes to push electrons through the wire. That's why voltage is sometimes called an electromotive force. You might wonder, well, how much electricity can we generate with this? Well, I can take some light bulbs and connect them to this power supply, or this generator, and I can crank it fast enough in order to light the bulb. Now, students, when they get these, they always want to do one thing, and you're probably thinking of it right now. Can we burn out the bulb? Well, I don't think you could burn out those in that arrangement, but if I take a single bulb, can I crank fast enough to make it burn out? And I did. Success.